In this video, we shall refer to the De Morgan's law. It is very important to understand how the operations of union and intersection interact with the operation of complementation. Please refer to this theorem. It states that if A and B are subsets of some set omega, then the complement of the set which is formed by the union of set A and set B will be the same as a set which is formed by the intersection of the complements of A and the complement of B. Besides, the complement of the set which is formed by the union of A and B is the same as a set which is formed by the union of complements of A and complements of B. Let us make use of the Venn diagram to illustrate the first statement of the De Morgan's law. We want to see that the two sets formed on the left-hand side and the right-hand side are the same. That means in the Venn diagram, they are represented by the same region. Let us first consider the case that there is overlapping between set A and set B. That is, their intersection is not an empty set. You can refer to these two bigger diagrams here to see how the region is formed after we perform this kind of intersection, union, and complement. We see that for both of the situations, we get the yellow region as the final result of the set. Therefore, these two sets are the same. Next, we consider the situation where A and B has no overlapping. That means their intersection is an empty set. And we found that based on these two descriptions, we also get the same yellow region in the Venn diagram. We can also refer to a more formal proof for the first statement of the De Morgan's law below. To repeat, we want to prove that the set which is formed by the complement of the union of A and B is the same as the set which is formed by the intersection of the complements of A and the complements of B. In order to show that two sets are the same as each other, we need to perform two steps. First, we need to show that if X is an arbitrary element of the first set, it is also an element of the second set. That means if we can find an element in the first set, then this element should also be found in the second set. Next, we also want to show that if Y is an arbitrary element of the second set, then it is also an element of the first set. Now, let us denote P to be the first set and Q to be the second set. We start to prove the first part. So, let's suppose that X is any arbitrary element of the first set P. By set notation, it means that X belongs to P. And now, in our situation, P is this set. To say that X belongs to a complement of a set means that X doesn't belong to this set. And if X doesn't belong to this set is a union of A and B. That means X does not belong to set A, and X also doesn't belong to set B. And for each of the situations, if X doesn't belong to set A, then it belongs to the complement of A. And also, X doesn't belong to B, that means it belongs to the complements of B. Since X belongs to these complements of A and complements of B, that means X also belongs to the set which is formed by the intersection of complements of A and complements of B. Then it is actually the set Q. Therefore, we successfully show that X is also an element of Q, and it means that the set P is a subset of Q because every element in P is also an element of Q. Next, let Y be any arbitrary element in Q. We want to show that if we found an element in Q, then it can also be found in P. That means we also want to show that Q is a subset of P. Now, since Y is an arbitrary element in Q, that means Y belongs to Q, which is this set. And as Y belongs to an intersection of two sets, it means that Y belongs to both the first set and the second set. Now, since Y belongs to the first set, which is the complement of A, it means that Y doesn't belong to set A. And since Y belongs to the complements of B, that means Y cannot be an element of B. And since both Y doesn't belong to A and Y doesn't belong to B, then it won't belong to the union of A and B. And because it doesn't belong to this set, therefore it belongs to the complements of this set. And the complement of A union B is P. Therefore, Y is an element of P. It means that whenever we have an element in Q, this element can also be found in P. Therefore, the set Q is a subset of P. Since we proved that P is a subset of Q and Q is a subset of P, it means that they are the same. Therefore, we have proved the first statement of the De Morgan's law. Please also use the Venn diagram to illustrate the second statement of the De Morgan's law and try to use this formal proof to prove that the second statement is true.